Hey guys, we're going to start chapter 13 today, which is our unit on trigonometry. Now, this first video is going to be what I title 13.0. It's not technically a part of the chapter. However, it's fundamental to everything we're going to talk about in this chapter. And we're going to be discussing special right triangles today. So you might have heard of special right triangles before. We're going to go through them. I think that's why it's not technically covered in our textbook. They assume you know it. We're just going to make sure right now. So there are two special right triangles that we are going to focus on. The first one is called the 45-45-90 triangle. So looking at this diagram, we can see here this triangle has a 90-degree angle. That's what makes it a right triangle, just a review of that. And then if you remember your symbols in geometry, these two symbols kind of on the inside of those angles indicate that those two angles have the same measure. Well, we know that a triangle has 180 degrees if you add up all of its interior angles. So if we know this is 90, and we know that these two bottom angles are the same, well, they have to be 45 degrees in order to add up to 180 degrees total. So a 45-45-90 triangle is one of two that are known as special right triangles. And we actually have measurements that are somewhat prescribed. We know if we know one of the sides of this triangle, we automatically know the other two side lengths. So here's what I'm going to kind of show is if we call that side length X, one of the sides across from a 45-degree angle, across the triangle. Well, again, from geometry, you might remember the other side length must be X as well. Angles and side lengths, their measures are kind of linked. And so if this angle matches this angle, then the sides across from them are exactly the same length. So 45 goes to a side length, the other 45 goes to a side length, those side lengths are the same. Then the hypotenuse of this 45-45-90 triangle will be whatever X is times the square root of 2. Okay, and that's just something, it's a rule that we have to know. We need to lock this in. So for example, I'm going to change colors. If I say that this side length is 7 centimeters, well then the other leg of this right triangle has to be 7 centimeters. And we would just say, okay, then the hypotenuse is 7 root 2 centimeters. So if we have the leg and we're going to the hypotenuse, we just have to multiply by root 2. Now, I wanted to show you on this triangle, I already have the 7 there. I'll add the 7 here. Why does it work out so perfectly with the 7 root 2? Because we know Pythagorean theorem, a squared plus b squared equals c squared. And so 7 squared plus 7 squared equals c squared. 49 plus 49 equals c squared. 98 equals c squared. Take the square root of both sides. Well, we know this is 49 times 2, and this is 7 times 7. And so 7 root 2 is going to equal c. So for those of you that were wondering, why does this root 2 thing work? It's because of the Pythagorean theorem. It's because in a 45-45-90 triangle, we know that a and b are the same. So a squared, b squared will be the same. That's what's going to cause us to kind of get that root 2 at the end. If you don't believe me, that's okay. You can try a couple other values. It doesn't just work for 7. It works for anything you plug in for those legs. So with this pattern in mind, I want to start here. I want to start with this problem. It says find the missing side lengths. This time we're given 8 centimeters, and it's the hypotenuse. Here's what I would do. I would put, and I always put in quotes, I just say this is my x root 2 side. It's my hypotenuse. And that makes this side my x side and this my other x side. Great. Now, how do I get from x root 2 to just x? Well, we can just use some of the algebra skills we know. I'm going to change colors and say, I know that 8 equals x root 2. So how would I figure out what x is? I'll divide by root 2 on both sides. Going to make a little room for myself. So that means 8 over root 2 equals x. But we know we can't have a radical in the denominator. We talked about that when we were going over radicals. So I'm going to say 8 over root 2 times root 2 over root 2. We're going to rationalize that denominator. 8 root 2 over 2, which is 4 root 2. 8 divided by 2, we can simplify that. So on this problem, to go from the hypotenuse to both of your legs, you need to divide that hypotenuse value by root 2. That's what's kind of being shown up here. That was a really thick pen. Let me try that again. Up here, we see to go from our x root 2 value to just our x value, we're going to divide by root 2 both sides, and it might require some simplifying of radicals. So right down here, we get it. We get this side is 4 root 2 centimeters, and this side is 4 root 2 centimeters as well. If you start with your x root 2, divide by root 2. On the other hand, what if we're looking at this triangle? One of the legs is 4 root 6 inches. We get another one for free, 4 root 6 inches, right? So 4 root 6, because they are both our x side. And then how do we get our x root 2 side? Well, we can start with x. So x root 2 equals, our x is just 4 root 6. And then we need to say times root 2, x root 2. So that gives us 4 times the square root of 6 times 2 is 12. Combine those insides of radicals. We can simplify this radical like we have all year. So 4 times 2 root 3, because I can pull a 2 out. And so we get 8 root 3. So this side length is 8 root 3 inches. All right, if we start with the hypotenuse, divide by root 2 to find the legs. If we start with the legs, then the legs match and multiply by root 2 to find the hypotenuse, using our radical skills to simplify anything that needs simplifying. All right, so I want you to take what we just did, put it into practice, solve these two triangles, the side lengths anyway, find the missing side lengths, pause the video, and then when you are done, unpause the video and check to see if you got them right. So if you're taking a look at my screen right now, hopefully you see that on the left-hand triangle in red, I got 11 root 5 for the side lengths of those legs of that triangle. Right here, just a quick shortcut to remind you guys, 11 root 10, we needed to divide by root 2 on both sides to get x alone. Root 10 divided by root 2, we can just divide the insides of those radicals. So root 10 divided by root 2 is just root 10 over 2, or root 5. And that's where this root 5 came from down here. On the right-hand side, in blue, I was given one of my leg lengths, 41 meters. And so that's my x. My other leg is also 41 meters. And so this one was actually really straightforward. For my x root 2, I needed to multiply by root 2. So my hypotenuse was 41 root 2 meters. So special right triangles, we'll come back to this 45, 45, 90, but really important. Hopefully those went well. If not, maybe rewind, listen again, or write down a question that you have to ask. But I want to go into the second of our two special right triangles. And we'll just start with this kind of blank triangle right here. This one is called the 30, 60, 90 triangle for somewhat obvious reasons. its three interior angle measures are 30 degrees, 60 degrees, and 90 degrees. So the legs are not the same length. As you can see, we referenced this theory from this theorem from geometry. The shortest angle, or excuse me, the smallest angle is across from the shortest side. The medium angle is across from the medium side, and the largest 90-degree angle is across from the longest side, the hypotenuse. So we're going to get three different angle measurements here. And here's what they are. Typically, we call the shortest side x. All right, that side is x. The hypotenuse then in a 30, 60, 90 triangle is 2x. It's double whatever the shortest side is. The shortest side is half of the hypotenuse. And then that longer leg is x root 3. So make sure you have this in your notes and make sure you have a good understanding. Whatever that shortest side is, that's usually where I start. That's kind of my baseline. We're going to call that x. The hypotenuse is double that measurement. And then the longer leg is the shorter leg times the square root of 3. So here we go. Let's say we're given this triangle and asked to find the two missing side lengths. Again, the first thing I would do is say, what side am I given? I'm given the hypotenuse. That's my, quote, 2x side. And I know my short side is x, and then my longer leg is x root 3. All right, we know 2x is 12. I think then it's a fair leap to say that my shortest side, x, will be 6 inches, just half of that hypotenuse, which then makes my longer leg 6 root 3 inches. Multiply the shortest leg by root 3. So looking at these two triangles, I'm hoping that explanation made sense of, we started with the hypotenuse, that was 2x, just divide by 2 to get my shortest side length, 6 inches, multiply that by root 3 to get my longer leg. Let's look at another one. So maybe sketch this triangle in your notes. I did try to put it at a bit of an angle to throw you off, but you can see it is a 30, 60, 90 triangle. It is labeled as such. And I mean, ask yourself, what side length are we given? Are we given my x, my 2x, or my x root 3? This looks like just my x, my shortest side length. I know my hypotenuse across from the 90-degree angle is 2x, and my longer leg will be x root 3. So x, double it to get to my hypotenuse, my 2x. So 5 root 3 times 2, I'll write it out. I need to double it to get my 2x equals 10 root 3. 10 root 3 yards were the units on this one. And then what about my longer leg? My longer leg I have written down is x root 3. So I'm going to take my x value that was given, 5 root 3, times root 3. And I know that 5 times root 3 times root 3, well, root 3 times root 3 is just 3. Square root of 3 times square root of 3 is just 3. So it looks like that longer leg will be 15 yards. We started with the shortest leg, doubled it to get the hypotenuse, multiplied by root 3 to get the longer leg. All right. First example, we were given the hypotenuse at the start. Second example, we were given the shortest leg. In my opinion, this is the trickiest one. That doesn't mean it's bad, but it is the trickiest one when we are given the longer leg to start. So 6 inches is my long leg. I know that's my x root 3 side. And I know that my shortest side is just my x, and then this will be my 2x, my hypotenuse. So let's do kind of what we did on the 45, 45, 90. I'm given that 6 equals x root 3. If I want to know x, I'm just going to divide by root 3 on both sides. And 6 over root 3, I know I cannot have a radical in the denominator, so I'll multiply by root 3 over root 3. Gets me 6 root 3 over root 3 times root 3 is just 3. And I can simplify that. 2 root 3 over 1, or just 2 root 3. So my x value will be obtained by dividing my x root 3 by root 3. X looks like 2 root 3 inches. My shortest leg. And then my hypotenuse is double that. Well, what's double 2 root 3? 4 root 3. 4 root 3 inches. So this is how we can kind of start with one side length and find the other two pretty easily with these special right triangles, okay? What I would like you to do, and I mean, it might look like a lot of problems, but I have 4 problems on the screen right now because this is an important concept that you feel very, very good about, these special right triangles. I would like you once again to pause your video and try working these 4 triangles out. They don't take too long. That's the good news. Once you are ready, then unpause the video and we will talk about these 4 problems. All right, hopefully you've had a chance to work those problems out. As you can see on my screen, I did not work them out, but what I did do was I added kind of the x root 2, the x root 3, the 2x. I added those placeholders, those labels to these 4 triangles, just so we know what we're looking at. On number 1, we start with the x side. The shortest leg was 5. That means my hypotenuse, my 2x, will be 10 inches. And then my longer leg will be whatever x was times the square root of 3. So that would make this 5 root 3 inches. 5 root 3. Not too bad. Number 2, little bit more legwork, not too much though. I know that x root 2 equaled 10 meters. Divide by root 2 on both sides. Root 2, not root 10. X equals 10 over root 2. Multiply by that root 2 over root 2 because we don't want a radical on bottom. This step should be becoming really familiar. 10 root 2 over 2, because root 2 times root 2, which means we're at 5 root 2. 10 divided by 2 is just 5. So 5 root 2 meters for each of these legs. Number 3, we're given one of the legs of our 45, 45, 90. That means we get the other one for free, 2 root 2 centimeters. And then to find x root 2, well, we know that x was 2 root 2 times the root 2 from our formula. Root 2 times root 2 is just 2. So that should come out to 4 centimeters. There are a lot of 2's going on there. But 2 root 2 times another root 2 comes out to be 4. Pause it if you need to and think about those radical operations from chapter 7. And then number 4, we start with the hypotenuse. It's 2x is 6 kilometers. That means my x side is just going to be 3 kilometers. And my x root 3 will be 3 root 3 kilometers. All right. So these 4 practice problems kind of represent everything you need to know about special right triangles. One question I get sometimes is, how do I remember which formula has the root 2, which one uses the root 3? It's easy to mix those up. Here's just a dumb trick that I've tricked myself into remembering. In a 45, 45, 90 triangle, there are 2 different side lengths, right? Because 2 of them are the same, the x's, and then an x root 2. 2 different side lengths, so we use x root 2 for that hypotenuse. In the 30, 60, 90 triangle, there are 3 different side angles, 30, 60, 90, so 3 different side lengths, short leg, long leg, hypotenuse, and that's why the long leg uses x root 3. Again, honestly, just something I tricked my brain into remembering. So if that helps, awesome. Last thing to talk about here. probably the two most important triangles in all of math. The 60, 60, 60 equilateral triangle might have something to say about that. But these are up there. These are two of the most important triangles in all of math. And lo and behold, they are 30, 60, 90 and 45, 45, 90, which we just spent a lot of time talking about. But what makes them so important is the fact that each of their hypotenuses, hypotenuse maybe, equals 1. And this is what we are going to spend a ton of time talking about in chapter 13, these special right triangles where the hypotenuse is 1. So really quickly, let's just focus in on this. The hypotenuse, which in a 30, 60, 90 is 2x, is 1. That means my short leg, my x, will just be 1/2. And then my longer leg, which is x times the square root of 3, would be 1/2 times the square root of 3. And I'm going to put that over 1 because I like multiplying fractions, seeing that denominator, root 3 over 2. This right here is an incredibly, incredibly important special right triangle, as we will see here in a couple sections. The 30, 60, 90 triangle, hypotenuse is 1, making the shorter side 1/2 and the longer leg root 3 over 2. Similarly, right here, this 45, 45, 90, we've got our x root 2 side is 1. So to find our x side, x sides, I should say, because there are two of them. 1 equals x root 2, so I'll say x root 2 equals 1. Divide by root 2 on both sides. X equals 1 over root 2. Get the radical out of the bottom. And x equals root 2 over 2. Again, you don't know why now, but you will hear very shortly, very soon, why these are two super, super important triangles. I would highly recommend making sure that you have these in your notes. You might not have a rainbow pen like I do, but make sure that you have them boxed, have them circled, have them highlighted, because we will be referring back to these a lot this chapter. So that's it for 13.0. That's our special right triangles lesson review. You saw them before in geometry, but hopefully this clears up any questions or things that you didn't remember about them. Take a look at your practice problems. If you have questions, then make sure you ask them or circle them so we can ask next time. But special right triangles, kind of the foundation for a lot of what we're doing in this chapter. Hope this made sense. I will see you in the next video with 13.1.